So here's another example from quiz number 3, question number 3, that shows a truth table, and you're asked to provide the sum of products form of this truth table. So the first thing we need to do is decide how we're going to represent this truth table. So just as before, whenever we see an A, in the A column, whenever we see a 1, that represents an A. And whenever we see a 0, that represents A naught. And I'll put these in that form. And the reason is because we're looking for when A, be it a sensor or any other kind of input, is true. The way we're going to represent A being true is with a 1. When A is not true, just listen to that English statement. When A is not true, it equals a 0. And so everywhere in the A column that we see a 0, we can replace that with an A naught. And generally, we do this in our heads, just to simplify it. And then everywhere we see a 1 in the A column, we're going to replace that with an A. And the same is true for the B column and the C column. Whenever we have an input, a true input on the B column, that's a 1. And whenever we have a false statement in the B column, that would be a 0. So that would be B naught. And so everywhere we see a 0 in the B column, we'll replace that with B naught. And everywhere we see a 1, we can replace that with a B. And again, the same is true for the C column. Everywhere there is a 0, we'll replace this with C naught. And everywhere that there's a 1, we'll replace it with C. And just to double check that you've done this correctly, you can try to notice the pattern that we mentioned before. The least significant bit inverts on every row. So we have C naught, C, C naught, C, and so on. And that's expected because in that column we generally have a 0, 1, 0, 1. The next column we generally have 0, 0, 1, 1, 0, 0, 1, 1. And that's been replaced now by B naught, B naught, B, B, B naught, B naught, B, B. Finally, in the third column, we generally have 0, 0, 0, 0, 1, 1, 1, 1, which is replaced by A naught, A naught, A naught, A naught, A, 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 A. So the frequency of each one of these is half. For every row you add, you'll have you'll basically double the previous row here. So so now that we've actually refilled out the table, I guess, or represented this table now as these forms, what does it actually mean when we have a 1 on the output? Well, to get this 1 on this output, we need to have A naught, and we need to have B naught, and we need to have C naught. So this is one product. So let's write that. A naught and B naught and C naught. And that represents that 1 on the output. We're going to skip this row because it doesn't have a 1 on the output, it's a 0, so it's non-consequential to our F value being true. So the next one that has a 1 on the output is this row. And so this is another product. And this is A naught, B, C naught. So we have A naught and B and C naught. And this is another product. And what we want it to do is represent all times in which f is 1. So what we would do is say this product, or this product, or this one, or this one, or this one. So that's where the sum of products comes in. And so between each one of these products that we're listing here, we're going to put a plus sign to represent the OR statement. So now that we've done the first two, the next one is right here. So we have A naught, B, C. A naught and B and C. Or the next row that outputs a 1. We're going to skip this one and go to this one. A or, and B naught and C. The next row we're going to skip again because it doesn't have a 1 on the output. And this last row is A, B, C. A and B and C. Oops. So now, in this unminimized sum of min terms formula, we should have just as many products here as we have ones in the F column. So we have 1, 2, 3, 4, 5 true statements. So we're going to have 5 products here. So let's see, 1, 2, 3, 4, 5. So that's correct. And that's how you basically turn a truth table into a Boolean expression. Another way of representing this is the sum, I call it the shorthand version, but it's the method where you have the output f as a function of a, b, and c equals the sum of the rest of these. So what I like to do generally is insert a column here and number these rows. Oops, I ran out of room here, so let me just make these rows a little bit bigger. And we always start counting in computers at 0. So we got row 0, row 1, row 2, row 3, row 4, 5, 6, and 7. And these numbers are the decimal numbers that represent the binary value that is originally in this column. So A naught, B naught, C naught means the exact same thing as 0, 0, 0. And so that's how we get this value for this row. And so now all we need to do is look at which row, the decimal number of which row that has a 1 on the output. So for every time we see a 1 on the output, we're going to list that row. So we have row 0, comma, row 2, row 3, row 5, and row 7. And so those are all the rows that we're going to represent, because those are all the rows that have a 1 on their outputs.